All right, we're in a new chapter, chapter 2, where chapter 2 kind of concentrates on different operations of rational numbers. And in section 2.1, we're going to talk about the use of integers and rational numbers. If you look at the term integers here on the screen and on your notes, you see that I have examples of numbers. They in fact happen to be integers. Integers are any like clean positive or negative values like -3, -2, -1, 0, 1, 2, and 3, you know, anywhere from like 5, 18, 27, -56. All of those are represented as integers. Anything basically that doesn't have like a decimal point in it, like 2.5, it's considered not an integer. All right. The next little subset of integers, we talk about whole numbers. Now, whole numbers are basically all the positive integers. You know, 0, 1, 2, 3, 4, you know, 5, 18, 27, 8, you know, 35. You know, anything that's a negative number that was an integer is not a whole number. Like -5 happens to be an integer, but it's not a whole number. Rational numbers are any values that can be written as a fraction. Now, any integer and any whole number, it can be represented as a rational number. You know, like so, like say like 2. 2 is a rational number because you can write that as a fraction of 2/1. Um, things that are not, well, I'll give you examples that are. So, like examples of rational numbers. So here would be some examples of rational numbers like 1/2, -1/8, 2/3, 0.3 repeating, because 0.3 repeating makes this a fraction of 1/3. Examples that are not would be like the square root of 3, pi, for instance. These are values that keep going on and have no specific pattern when it comes in their decimals, so you can't write them as a fraction. Okay. Looking here, this is the number line. If you look at 0, anything to the right of 0 represents positive integers or positive rational numbers. Same thing goes for the left side, but it's negative. In our homework, we're going to be asked to do some different problems. What we're going to do is you're going to be given a set of values, and you're going to tell whether each value in a list as a whole number, an integer, or a rational number. Then from there, you're going to order them from least to greatest. Now, I found the best thing to do is to make a chart. So what I'm going to do is I'm going to make this chart. And I'm going to put numbers here, and I'm just going to put the numbers that are given here in this specific example. So I got 3, I got -1.2, I got -2, and I have 0. So all of these are going to be on a chart, and I'm going to put in whole numbers. I'm going to put in integers, and then rational. So I can then figure out which category it falls into. So if you look at the number 3, is it a whole number? Yes, it is, because it's a positive integer. That means it's also an integer. And is it a rational number? Yes, because you can make it into 3/1. If I look at -1.2, is it a whole number? No, it's not, because it's not, well, for one, it's negative, and also it's not a clean value. It has a decimal point attached to it. So that means if it's not a whole number, then it's not an integer. But you can make that into a fraction. 0.2 is can be represented as 1/5, so it's -1 1/5. So yes, this can be represented as a rational number because it is indeed a fraction. -2, it is not a whole number because it is a negative value, so automatically it's not a whole number, but it is an integer, and it is a rational number. And 0 would be yes in all 3 categories. And now the last thing, they want you to order the numbers from least to greatest. So if I look at this, I have two negative values. I got negative 1.2 and negative 2. The smallest value makes it negative 2. From there, it's going to be negative 1.2. Then it's going to be 0 and 3. Okay? Same thing goes for example B. I'm going to draw my table. It's going to help me out. Put my numbers here. I got 4.5. I got negative 0.75. I got negative 2.1. And I got 0.5. So again, same thing on the right whole numbers. I got integers. And I have rational numbers. So we got little boxes and go from there. So 4.5 whole numbers is no, integers is no, but rational numbers is yes. Same thing goes here. We've got no, no, yes. We have no, no, yes, and no, no, yes. The reason why neither of these, none of the four are whole numbers or integers is because they all have the decimal point attached to them. But they are rational numbers because all of them can be represented as a fraction. And from least to greatest, I'm going to say it's negative 2.1. I got negative 0.75. I have 0.5 and 4.5. Okay? And I'll do the last one. So the last one here is, again, same thing. I got numbers here. I got 16. I got negative 1.66. I got 0.1. And I have negative 0.1. So here, again, whole, integers, and rational. I know the table isn't that great, but it is what it is. 16, I can say that, yes, it is a whole number because it's a positive integer. And I say, yes, it's also an integer, and yes, it's a rational number. And for the rest of them, I can say no for both whole numbers and integers because they got the decimal point. And they can be written as a fractions. So they're all yes to integers, or rational numbers, I'm sorry. Last thing I need to do is write them from least to greatest. I have two negative numbers, but the smallest one is negative 1.66. Then I got negative 0.1. Then I have 0.1. And then last I have 16. Okay? And also in this section we get into absolute value and opposite value. Absolute value is the distance a value is to 0. So if I had my number line here, I had 0 here. Instead I went 1, 2, 3, 4. And then I got negative 1, negative 2, negative 3, negative 4. So say I had points at both the value of 4. I wanted to find the absolute value of 4 and the absolute value of negative 4. And again, this is just the distance that value is to 0. So if I look at 4 here, I'm going to go 1, 2, 3, 4. So the absolute value of 4 is in fact 4. And for negative 4, it's going to be 1, 2, 3, 4. It is also 4 because distance can't be a negative number. So the absolute value of both positive 4 and negative 4 happens to be a positive 4. Opposite value is when you have two values that are on the same side, same distance to 0. So again here, if I have 4, the opposite of 4 would be the negative 4. And usually it gets represented generally as negative a. So if you're looking for the opposite of it, then you go from there. So then for the rest of these examples here, I'm going to try For the given value A, I need to find the opposite value of A and the absolute value of A. So if I look at A equals 6, my opposite value is going to be negative 6, and my absolute value is going to be 6. Remember that the absolute value is always going to be positive. So for A is negative 18, the opposite of negative 18 is positive 18, and the absolute value of negative 18 is also 18. If I look at negative 1 and 1/9, the opposite is going to be 1 and 1/9. The absolute value of negative 1 and 1/9 is still a positive 1 and 1/9. And the opposite of negative 2.7 is going to be a positive 2.7. And the absolute value of negative 2.7 is a positive 2.7. Okay? And that is being able to use integers and rational numbers. Hope this helps. Until next time.